In this video, we'll discuss levels of cognitive demand in mathematics. Now, the levels of cognitive demand was developed by Dr. Stein and Dr. Smith, and they were looking at ways to help teachers reflect on the tasks that they create for their students, and especially examine from when they receive the materials to how they set up the task to then how they implement it with their students and how that's impacting student learning. So when we look at the levels of cognitive demand, there are actually 4 different levels separated into 2 specific categories. There's the low demand, which goes from memorization to procedures without connections, to the high demand, which are the procedures with connections and doing math. When we look at a task and we reflect on what level of cognitive demand the task is, we're looking at the entire task, not just individual parts. And we want to look at how much cognitive demand is required to complete the entire task. Also, when we think about it, we have to take into consideration what are the grade levels and the ability of the students that we are working with. So a task that may be at a high level for one grade or for one set of students may be a relatively low demand task for another set of students due to their own experiences or their mathematical abilities. So let's look at the 4 different levels. First, we have memorization. This is the lowest level where we're looking at quick recall facts, properties, formulas. We're not looking at something that requires any computation, and we're not making connections between meaning of the memorized fact to the conceptual understanding. 2 examples of questions. How many pennies are in a dollar? Most students should easily say 100 pennies before a dollar. And then was the quadratic formula? In Algebra 2, that is something that should be a very quick fact that students should know. When we think about procedures without connections, we're now having students do procedures and actually have to work through a problem or a task. But what we're focusing on is solely the answer. There's little aspect that's focusing on the solution, on the process or the conceptual understanding behind that procedure. It's primarily focused on doing a procedure, finding the solution, and what the procedure is typically fairly obvious. Some examples of this below are the idea of just saying graph this linear equation, where students recognize it's in slope-intercept form with a slope of 3 and a y-intercept of -7. Another example, even though this is written as a word problem, it's still a pretty low demand activity because they recognize this is the cost of the coat, and I'm taking 30% off, so I'm going to take 30% of $84, subtract that from 84 to get the new price of the coat. That's a very set procedure that has been taught to them. Now when we start to get to the high aspects, we start with procedures with connections. Now here we may be looking at algorithms or procedures, but the emphasis is really on having students explain and build that conceptual understanding behind the process. There's likely opportunities to look at multiple methods or multiple representations of the specific concept or even that process. And often it's trying to build the broader conceptual ideas to complete the task. So we focus often on the process, not on the solution, even though the solution may be part of the final requirement of the task. So here's an example of such a problem. In 2011, there was an earthquake in Charlottesville that was around 5.8 on the Richter scale, while in San Francisco in 2014, there was one that was at 6.0. Does that mean it's only about 3% stronger than the Virginia wire? Why not? Now, why would this be procedures with connections? Well, there's a couple aspects to this problem that require students to build their connections. One is recognizing that the Richter scale is logarithmic. And so what does it mean to go from 5.8 to 6.0 on a logarithmic scale and how those relate? Additionally, you're dealing with the exponents and also the relationship between those 2 values. So there's a lot of different aspects with that underlying component being understanding and comparing logarithms. Now when we get to doing mathematics, one of the things that's recognized is that the problem will not have an explicit and likely won't have an implicit method or pathway to solve the task. You're looking typically at requiring different methods for different aspects of the task, and often these tasks can have multiple solutions, so they're more open-ended problems. They're going to require students to delve deeply into various mathematical concepts and relationships, which can often cause them to have some anxiety as they're trying to go through the problem. So these tasks are going to require students to have a high cognitive load, which is why some of that anxiety may occur. So here's an example. Here's a set of data about tuition at four-year institutions, and the question's asking, what should I expect to pay when my daughter starts school? Well, not only am I having to figure out, well, when will she start school? How many years from the data do I have? But then how do I use the data that is given to me? Do I plug it into a linear model, a quadratic model, a power model, a logarithmic model? What fits? Why does it fit? How do I plug that in? Is that the expectation? Even as I stretch this over long term, thinking about the way that finances work and whether there's going to be a peak cost before it starts to come down. So there's a lot of different relationships that could potentially occur within this single problem for students to go through and solve it. Hence why there's multiple pathways and potentially multiple solutions. Now, it may be worthwhile to also think about this in relationship to Bloom's taxonomy. And you think about Bloom's taxonomy starting from the lower end and going up, we know that remembering would be really related to that memorization aspect of cognitive demand, but also there may be some aspects in understanding that may fall into memorization. Procedures without connections is going to require a lot of understanding, but also maybe integrate some of the applying. Applying is that weird combination in Bloom's that sometimes can be a high-level application, and sometimes it's just a very low-level application, but requires students to actually do the procedure. When we start thinking about procedures with connections, we're looking at problems that really fall from applying up through evaluating, depending on how the evaluation problem is set up, especially if it's procedural based. And then when we get to doing math, we're really looking at high-level evaluation problems as well as students creating their own material. And if this may be another way of relating the idea of the tasks that we're looking at with high demand and low demands, think about how may they fall within Bloom's taxonomy.